So this is our Haimer Tool Dynamic Comfort Balancing Machine. So as mentioned before, Haimer is the only tool holder builder in the world that makes a balancing machine to become the worldwide standard for balancing tool holders and grinding wheels. How it works is very simple. So we take our tool holder, so now we've assembled it as it will actually run in the machine. Yes, this tool holder is balanced at G2.5 at 25,000 RPM. It's a shrink fit chuck with the best balance repeatability in the market, but we've introduced a cutting tool. So now we added the full assembly as it will run the machine tool. We clamp the tool in the machine, the balancing machine itself. It's clamped as it would be held in the machine tool spindle. In this case it's HSK, it's grabbing and drawing the tool in with face contact. If it was CAT 40, BT 30, it would actually be grabbing on the pull stud and grabbing the tool holder into the machine itself. We shut the hood. The operation is extremely simple. Press the green button. This will start the rotation to actually start the measurement of the tool. This tool is trying to be balanced at G2.5, which is a quality grade dictating permissible imbalance at 20,000 RPM. The tool finishes the first rotation. We index the tool holder 180 degrees in the spindle, and that's to take the unbalance of this spindle out of the equation. So now we're truly just getting the unbalance of the tool holder assembly as it will run in the machine tool spindle. We take one more reading, and then we're going to get our results. So now the machine stops. We look over to our computer screen, and you'll see that, it's red. We are not balanced at G2.5 at 20,000 RPM as we requested or wanted to be. Instead, we're balanced at G2.5 at 1,756 RPM. At the 20,000 RPM, we're currently at G28.4, which is way out of spec per what we want to be running here. So what do? Well, again, the machine told us that we're heavy at this location. Now we do have an option of actually drilling to remove material or milling to remove material, or we have rings where we can displace material. In this little demo we're going to show you today, we're going to actually add weight via our shrink fit holders that have these drilled and tapped holes. So the screen itself gives me two indications of where to add weight. In a perfect world, we'd add weight exactly 180 degrees opposite of where we're heavy, but you don't always have a hole there, so it's going to give me two spots to add weight. In this case, it's telling me at angle 180 to add a weight of 0.78 grams. So we have a little tackle box here full of weighted screws. The weighted screws have different colors, they have different lengths. And we look and we say, okay, 0.78, what do I have? Well, I've got a screw that's 0.77, that's close enough. We grab that screw out of the box, put the box down, and add the screw to the holder. We have a little screwdriver here. Line it up and add the screw to the holder. Now we bottom these screws out. After you bottom the one screw out, we look onto our computer screen. It tells me, okay, there's another angle to add weight. It's at angle 270, which lines up with the spindle face. It tells me to add a weight of 1.05 grams. So again, we look in our tackle box here, there's 1.06. Very close enough. So then we grab that weight, that screw, and we're going to add that to the holder. Again, just lining up the screw into the thread of the holder and bottoming it out. After we bottom it out, we're going to check this to make sure that I did this correctly. So basically, after bottoming it out, we shut the hood, start the process again. So again, it's going to ramp up to the 1100 RPM. At that point, it will take a reading, and then we'll index the tool 180 degrees. Why are we doing this? Because really, in order to get the max out of your machine tool, you want to make sure that your tool holder assembly is balanced. And I use the word assembly because that's important. Yes, the tool holder is pre-balanced, but you want to look as it will actually run in the machine. If you have vibration, if you have problems, the operators are going to slow down the feeds and speeds, and the parts will get done slower. Also, if it's a super critical finish application, like in a die mold application, let's say, you'll actually have quality issues that relates to the part tolerances and surface finishes. So now we have virtually zero unbalance. We're actually at G 0.9 at 20,000 RPM. So you see the process of balancing a tool is very, very simple. but it's very important and often overlooked. It should be considered, especially if you're looking at the Industry I 4.0 concept of lights out machining and consistency in the shop. Then balancing becomes extremely important. So as you see with this example, most people say, shrink fit holder, I don't need to balance. In this case, this holder, when the cutting tool was introduced, was way out of balance. Now we balance it within a matter of minutes and we're ready to go.